In today's video, we will be talking about the 7 strongest new drones. 7. HUUVER is an acronym for Hybrid UAV-UGV for Efficient Relocation of Vessels, and it is being developed through a European Union project led by Poland's Cervi Robotics. This drone is going to fill the lack of existing UAV solutions. It combines the functions of both flying and driving machines. In its present prototype form, the drone measures 137 centimeters long, 84 centimeters wide, 56 centimeters high, and it weighs 23 kilograms. When the vehicle is required to travel along the ground, it uses a pair of linked treads, and it can do this for up to 10 hours per charge of its lithium battery. When it needs to fly, it fires up its 8 horizontal propellers, which sit aligned with the treads. It can fly for up to 20 minutes. The drone can be piloted remotely in real time by viewing output from its gimbal-mounted Sony 4K optical and FLIR thermal imaging camera. It can also fly autonomously, guided by a Galileo satellite positioning system, a sensor that helps it to spot and avoid obstacles with help from an onboard NVIDIA Jackson AGX Xavier microprocessor. 6. Shape-Morphing Drone. Scientists from Virginia Tech in the US, led by Michael Bartlett, have built a shape-shifting robotic drone that can change shape, hold the shape, and return to the original shape. It can also do this over and over. It can perform diverse functions under different conditions, and in case of damage, it can self-heal. According to Michael Bartlett, one of the challenges was to create a material that was soft enough to dramatically change shape, yet rigid enough to create adaptable machines that can perform different functions. The scientists then used the Japanese art of kirigami, where shapes are made out of paper by cutting to create a structure that could be morphed. An exoskeleton was then developed out of a low melting point alloy embedded inside a rubber skin. When stretched, this composite holds the desired shape. This feature is perfect for soft morphing material that can become instantly load-bearing. The team incorporated soft, tendril-like heaters next to the alloy mesh so the structure can return to its original shape. The heaters convert the metal to liquid at 60 degrees Celsius. The composite skin keeps the melted metal contained and at the same time puts the material back into the original shape. Applying this with the onboard power, motor, and control, the team was able to create a functional drone that autonomously morphs from ground to air vehicle. 5. Iconocraft. Iconocraft uses electrohydrodynamics to provide lift and thrust in the air without combustion or having to move some parts. Current designs, however, do not produce sufficient thrust for manned flight or for carrying loads. Each Iconocraft is constructed by hand from 41 different components with the aid of an aluminum assembly fixture. Various components are fixed in place by a combination of UV curable epoxy and silver epoxy. These ions are drawn towards a negatively charged grid, then they hit air molecules and generate momentum. These drones could offer extremely silent flight. Iconocraft is an excellent micro-drone because it is easier to scale down its components compared to propeller-driven drones. 4. LAZA Micro-Drone. Engineers at the University of Bristol built a tiny flying robot that flaps its wings more efficiently than an insect. It does this by using a unique electrostatic zipping mechanism. The drone uses an artificial muscle system called LAZA, a liquid-amplified zipping actuator, which requires no transmission. The team says that the LAZA system allows users to control the amplitude and frequency of the flapping wings. Each of the drone's wings is made up of an electrode that sticks out from between 2 smaller electrodes at the base. A high voltage is sent through each of those base electrodes in an alternating pattern. This attracts the wing's electrodes to each other in turn. In tests, this drone was able to fly across the room at about 2.5 kilometers per hour. It was able to flap its wings over 1 million cycles with no drop in performance. This proves that the drone will be able to fly long distances. The team claims that the LAZA system could lead to the invention of smaller drones that could be used in exploration, search and rescue, environmental monitoring, or even planet pollination. Make sure you subscribe to this channel and give this video a like if you are loving the content. 3. Sub 250 by Quad-Mover. Sub 250 was built to reach 250 kilometers per hour. It houses a T-75 HQ prop at 3600 kVs, giving this mostly 3D printed drone incredible flight capabilities. It doesn't use GPS or self-stabilization because it is flown in acro mode. In other words, it would take a lot of practice to master flying this type of drone. 2. Reconfigurable quadcopter. Scientists at UC Berkeley's High Performance Robotics Laboratory have developed a mid-air reconfigurable quadcopter. This drone uses unactuated hinges, which means that reverse thrust or gravity is all that's needed to cause each of its arms to flop down. This makes it possible for the drone to maneuver easily, even in tight or narrow openings. For example, if the drone needs to squeeze through a narrow vertical opening because it travels horizontally, it reverses the direction of thrust on two opposing arms, causing them to fold down. And because the thrust axis of those arms are offset from one another, the yaw torque produced by them equalizes the yaw torque generated by the other two arms. As a result, the copter will be able to pass through the opening smoothly, and the arms can also be used to grasp a flat-sided box by pinching it from either side. That box can then be flown and released at another location. Also, if the hovering drone needs to drop down through a narrow horizontal opening, it reverses the direction of thrust on all four propellers, causing all the arms to fold down. As the drone proceeds to free fall, its vertical orientation is controlled by alternating the thrust of the propellers relative to one another. After passing through the opening, the thrust is then reversed back to its original state, raising all the arms back up again. The quadcopter can now resume hovering before moving on. 1. Crimson Spin. A design for a one-person helicopter was sketched by Leonardo da Vinci in the late 1480s. It was to be propelled by an aerial screw. Engineers from the University of Maryland decided to turn these sketches into a real flying machine. They call it Crimson Spin. The device is a small, unmanned quadcopter drone that uses the concept of an Archimedes screw to push against the air to obtain flight. Austin Pratt, who is part of the project's engineering team, built Crimson Spin for his master's degree and flew the device over several short journeys. He also presented the first video of the aircraft flying at the Transformative Vertical Flight Conference. The drone has 4 wings made from plastic and is shaped like a corkscrew. However, instead of having someone pump or handspin them, just as proposed by Da Vinci, these wings are powered by electric motors and batteries. Also, creating a single shaft design as seen in Da Vinci's sketches would have been very complex and would require some of the technology used in modern helicopters. The unique aerodynamics of this drone addresses many challenges faced by VTOLs because it produces less downwash and it would likely be quieter than conventional propellers. Although this is a small drone, Pratt believes it could be enhanced through geometry optimization and research into the performance in different flight regimes. He also believes that it can be scaled up to carry 1 passenger. Pratt is not working on this project anymore, but he says the research may continue at the University of Maryland if there is interest and funding.